All right, we're going to make a start then. Thanks for coming, guys. This lecture's going to be a bit of a new one for me. So based on the feedback we got last week and some thinking that George and I have been doing, we've kind of revamped the curriculum a little bit this year. The biggest bit of feedback we've got from you guys was basically that we need to not slow down so much, but maybe just go through some of the stuff we've gone through again, maybe take a bit of time to consolidate the stuff we've done before we move on to some of the more advanced stuff that I want to cover in the last couple of lectures. So that's exactly what we're going to do. I'm going to spend probably the first half-ish of this lecture going through, actually, let's first talk about what's left on the course. So the first lecture, there's 3 left. The first of those 3 is this one, so I'll talk about this in a bit more detail next slide. Next lecture, I think, is probably the most interesting one. So if you can make that lecture, please do, because it's probably the most relevant for most people. That's where we're going to bring stuff into the real world. So that lecture is a really good one. We're going to basically talk about how to get away from this sort of online Python window and actually making your own Python programs and doing useful stuff with them. So we're going to talk about like data manipulation and like graphs and fun stuff like that that you might actually use if you're from sort of the sciences, which most of you are. And also like how you can do some just interesting stuff by yourself. So that will probably take us to the end of next lecture. And then the final one, I've got some little bits that I really like to talk about, primarily because I think they're not taught to beginners very well at all, and they really should be. So it's kind of concepts that promote what we call like good programming practices. And they're kind of taught quite well to computer scientists, particularly at university level, but they're not really taught A-level computing or GCSE computing, and they're definitely not taught to people who learn programming through other industries or other degrees. So it's what I like to focus on towards the end of the course. So it's kind of a bit more theory, a bit more content delivery from me, but that one should be really interesting, and I'll talk a bit more about that probably at the end of the next lecture. It's normally lecture 4, but we've moved it. So we would have been doing that today. We're not. So this lecture is primarily going to be going through basically everything we've done with a little bit more. So now we've got like sort of the full context, because everything we've done so far basically gives us the building blocks that you need for most of the programming you'll ever do, which sounds kind of weird because we've not actually done that much, but the stuff we've done is the sort of fundamental building blocks that build basically every program. So we're going to go through them, now that we've got sort of that full context, we're going to go through them a bit more slowly, with a bit more care, and we're going to try and put them together in a way that sort of makes sense and is a bit more organic, and a bit less rushed as well, because I know that some of the examples have been quite rushed. And hopefully that'll be both between as a group, so I'll do some live coding and you guys will help me, by which I mean I'm not going to do very much, I'm just going to do the typing, and I'm going to just pick on people, probably. And then we'll do some stuff sort of like we've done before, where we'll give you a question, you guys have a go, and we'll send people running around to help. Does that sound good? Are there any questions or suggestions? Cool. So this is what we hope, I hope we all are by the end of this lecture. So the thing on the left is basically the topics we've done. So it's variables, control flow, so if, elif, else, iteration, so that's what we call the while loops and the for loops, lists, so our sort of basic data structure, and functions, which I know people were having issues with last week because we didn't have time to go through it too well, or not as well as I'd like. Things we'll have done are, we'll have made sort of simple programs that use these techniques so that we know we understand them, then perhaps more complex programs that combine them and use them together. And hopefully towards the end, we're going to start talking about writing these programs not just so that they're functional, but so that they're clear and reusable, which we're going to talk about more later. So that's kind of my little intro for today done. We're going to start with a recap, but there's loads of pizza here, so I guess I'm going to feed you now. Is everyone happy with that? Can we bring in the food? So one of the biggest things we've talked about, and we've come across these in basically every other topic, is variables. So can someone remind me what a variable is? Let's start with that. What is a variable? Still eating pizza, aren't we? Yeah. Do you want me to wait or just talk at you for a bit? All right. No one's ever said that before. So basically a variable is a piece of data that you're naming for your program to reuse later. You might assign a name to a variable and then change. So the name acts basically like a label. So in this case, it's X. It can be any word or letter. And we assign an initial value like this using the single equal sign, which is not the same as an equality sign. It just looks like one. And this is saying that the label X has the value 5. And as we've seen, we can change the value that that label points to. And we can reuse that label elsewhere. And it gets replaced with the value that it points to. So basically, every time you see a variable, which is any kind of word that's not in quotation marks, and it's not in an assignment like this, it will be replaced with whatever the program thinks that label is currently pointing to. Does that make sense? Okay, cool. Can I get a show of hands of who's like super happy with what a variable is and what it does? Nice. So I'm going to be doing like that show of hands at the end of every topic, and we're going to keep on the topic until everyone's hand is up. Basically, that's what this lecture is. Should we talk about types? Yeah, let's talk about types. So, can someone remind me what a type is? It's kind of on the board, but... Or has anyone got an idea of what I might mean when I say the type of a variable? So, if a variable is a label... Oh, is that a hand? Yeah, so the answer was that it's the format your variable is in, which is a pretty good way of explaining what a type is. So when you assign a label to a bit of data, Python, so your label is your variable name, so X, and your data is whatever it is, so 5 or Harry or Lloyd or a list of numbers. Python will look at the bit of data that you've just labeled, and it will try and decide what type it is. And the type is, as was sort of correctly said over there, the format or the kind of data that you've just labeled. So that could be a list, it could be a string, so a string of characters, it could be one of these number types, so we've mostly seen integers. The tricky one, which is kind of like less intuitive, is Booleans. So we had a comment last week about wanting to understand a bit more about Booleans. So could someone else maybe tell me what a Boolean is, or describe what a Boolean is used for, or why it matters? Yeah.
When they say all ones and zeros, I think one is true, 0 is false. And it's good when you have like an and or system.
Yeah. So the answer there was that a Boolean is kind of like a 1 or a 0, or a true or a false. So a Boolean is a bit of data that literally says, this is true, this is false. It's sort of like you're labeling the concept of truth. If you did X equals true, then X is a label that points to true, which doesn't really make sense on its own. It doesn't seem useful by itself. But the reason it's useful is that you can label sort of the answer to a question. So I could say, for example, actually let's do this. So for those of you who haven't seen this before, I think I recognize everyone's face though. Is everyone here new, like not been to any of these lectures? Oh, there are a couple. So you won't have seen this, then this is Replit, repl.it, which is the website we've been using for our Python. So what you'll basically never see, or you will sometimes, but you'll very rarely see something like X equals true. What you might see is something like X is a number that we get from the user. If you don't know what this means, don't worry about it. This just means X is a number. And then we might say is big is our new variable, which has the value of the answer to the question, is x less than 10? I'm going to move the cursor, and I'm going to make that bigger. So what we've not written x equals true. What we've written is, we've not written is big equals true. We've written, that's a terribly named variable. Fail. So we've not said is big equals true. What we've said is big is equal to the value of is x bigger than 10. So this statement, expression here, will reduce to either true or false. Either x is bigger than 10, and it will be true, or x is not bigger than 10, and it will be false. Zoom in more, okay. I think I might struggle to go in anymore. What this means is that we can then make use of this is big as a Boolean variable later on. So if you're struggling with the idea of something being like a variable being true or false, or having the value of true or false, try and think of it as a variable that's capturing the answer to a question. Like you might not know the answer to that question yet. You might need more information. So we don't know the value of this until we know x. So the variable is big represents the answer to the question, is x bigger than 10? Does that make more sense than it did before, or less sense than it did before? More? Nice. Okay, I'm not going to linger too long. Like, Booleans are important, but it's more important that you know how to use them rather than what they are, if that makes sense. So I'm not going to linger too long. Maths. Input. Can someone quickly describe to me what they will see when they first hit run on this program? Yes, Charlie.
Not 100% sure that you'll see, but the input is a string.
You're right.
Integer, so it won't do the maths in the print statement.
You're absolutely right. Before that, though, before you've even put in a number, what happens when you run this program? What output do you see? Yeah. Please enter a number, and then... So, yeah. So what happens is the program will wait for you on this statement. So it will say, please enter a number, and then it will wait for you to input something. It will wait for you to type in something and hit enter. And as Charlie so correctly told us, input, we say it returns a string. It's a function that returns a string. We're going to come back to that later. So this returns a string, and Python then will do something weird with this. It won't times the number by 2 if you put in a number. It will double up the string. So anyone got any questions about that? There's quite a lot on that slide, actually. Any questions about anything else? Python related. Cool. Okay, very, very quickly. So these are the important things for Booleans. The important thing is that every operator... Oh, I need to make that bigger, don't I? Every operation, or every operator you see here, returns a Boolean value. So these are the questions that you get answers to. So this is saying, is the thing on the left and the thing on the right true? Is the thing on the left true, or is the thing on the right true? Is the thing on the left bigger than or equal to the thing on the right? Et cetera, et cetera. Any of these things that people are unhappy with? We've not necessarily used all of them, so they might not be clear. Yeah?
What is the one with the exclamation point here?
So the question was about this one. So A exclamation mark equals sign B means A not equal to B. So this is saying, does A have a different value to B, basically. Cool. Right, the next big one was control flow. So, can someone remind me, this feels like a revision lecture. There is no exam. Can someone remind me what control flow means? Or what it is, or what we use it for? Any of the above. Yeah, so the answer from Angelo, is it Angelo?
Yeah.
Names. The answer from Angelo was that control flows are basically a way of choosing the code you run based on certain conditions. Or in other words, controlling the flow of your program. So the way we typically see this, there are other ways, but the way we'll typically see this is with what we call an if statement, or an if-else statement, or an if-else-if-else statement. You can have any number of these, by the way. You could have if, elif, 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 else. And this is basically what it does. It's if, it's a condition, so this is a question that has an answer of true or false, and then something you want to do when the answer to that question is yes or true. And then it's going to go through each of these in turn, and if it gets to the else, it will always do this. If there is no else, it will just continue down with the rest of the program. So, pop quiz. If you've got if, elif, 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 like there's 20 elifs and then an else, with all kinds of different conditions in there, what is the maximum number of these little indented bits that will ever be run? Let's move it to a concrete example. This one on the page. Forget that it's x greater than 10, x less than 10. Pretend it's any condition at all here. What is the maximum number of lines that we print out? Or could ever print out? Say that a bit louder, Charlie.
1.
Yeah. So you can only ever print, or you will only ever execute, one of these indented blocks. The moment it finds that one of these conditions is true, it will just skip the entire statement, go right to the end. So if it finds that x is indeed bigger than 10, it will execute this line, and it will ignore all of this and go to the bottom. That makes a horrible noise when I scratch that. I'm not going to do that again. Yes? Mm-hmm. Yes, there are. Not. So the question, are there ways to shorten if you had, say, like 20 elifs that had, it started at, say, 10 and then went 20 and then 30 and then 40 and then 50 and then 60 or whatever. Well, obviously you'd have to have less than, so if it was like bigger than 10, bigger than 9, bigger than 8, bigger than 7, bigger than 6, whatever, is there a way to shorten it? And the answer is kind of yes, and kind of no, in that yes there are, but they're all going to be very situation specific. So you'd probably want to know a lot more about what your specific scenario was and what you wanted to do and how often those conditions would be true, and then you'd decide. I'd say the number of circumstances where you actually need that number of condition checking and that kind of behavior and this kind of if, elif, elif, elif structure, it's probably very rare. Usually problems that end up looking like that have a more elegant solution. So if you're constantly checking, say in the example we use, if it was 10, 9, 8, 7, 6, 5, 3, if I'm looking at that, what that suggests to me is you're actually doing something based on the actual value of the number, and perhaps there's some kind of maths you can do with the number instead of this horrible checking of the value every time. Typically, if you've got a huge if statement with loads and loads of cases, or they get nested, what that says is you need to restructure your program. You need to rethink the problem to avoid that kind of mess. Sorry, that's not a very concrete answer. Did that kind of answer your question? Okay. Good question. Cool. Is everyone happy with control flow? I'm not seeing a lot of hands.
I can't tell you if everyone's happy.
That is true. You're absolutely right. Is anyone not happy with this?
Now that's a much more efficient function, isn't it?
It is. 10 points to Gryffindor, or whatever house you're in. Should have said Ravenclaw. That would have been funny. Right. So, we had a little exercise where we made a little Marco Polo game. It looked a bit like this, but this only played once, and we decided that maybe we would want to play it more than once. So the question, which is sort of on the board, is we want to maybe play it every time they get it right, or play it n times, or maybe indefinitely. So what programming construct or what concept are we going to turn to answer these questions? A while loop is one of them. Charlie? For loop is the other. So what is the general sort of class of things we're talking about? We're talking about while loops and for loops. I've only used the word a couple of times, so don't be alarmed if you can't remember. Someone say iteration? Were you going to say iteration as well? So the answer there was iteration. So the idea is that we're doing something iteratively. We're doing things multiple times. And while loops and for loops are the most common examples of those. Certainly the only ones you need to worry about. So we talked about while loop like this. It's kind of like an if statement, except it does it a lot. So it will check the value of this condition. It will do the thing. And then once it's finished doing the thing, it will go back to the top and check the condition again. Everyone happy with that? Is anyone unhappy with that? Let's keep with that format. People don't like admitting they're unhappy, though. Teaching is hard. So, as this really exuberant message over here will testify, this program runs forever. Can someone explain why? Is that a hand? Yes. So the answer there was that this is indented. So this is the code that's run within the while loop. But why does it run forever? Yep.
True is always true.
True is always true, absolutely. So the condition we've got on this is while true. So what this means is that every time it finishes running this indented block, it's going to come back to the top and say, is true still true? Yes. Okay, let's do it again. Is true still true? Yes, let's do it again. And it's going to do that forever, basically. So what solution would we turn to stop this running forever? What could we do instead of while true?
Set it to a variable and then have some input be false and then have that variable set to false.
Yep, so indeed the solution we turn to is this kind of thing, which you'll see quite a lot, is that you sort of initialize a variable that says whether or not you want to do it again. You initially set that to true, because you do want to do the thing. You want to do the thing at least once. And then somewhere, if certain things happen, i.e. you can use control flow to decide when you want to stop. You set that to false, and that means that when we go back to the top to check the value, we now see that it's false, and we stop. Can I get a hands up if you're happy with that? There's going to be a lot of that this lecture. I'm really sorry. I know people hate when teachers do that. I hate when teachers do that. But you kind of understand why they do it once you get up here. So, there's a couple of things I want to go over with for loops. So, can I get a volunteer to explain, not you, George, to explain to me what I is in this for loop? Because this is a tricky question. Not you, Angela. You've answered too much today. Because I gathered that the sort of subtlety of what I actually is kind of not well delivered on my part. Charlie, do you want to have a go? So the answer was, is it a counter? And it is a counter in this specific case. Can we be a bit more general than that? Like, I'd be happy with saying I is a counter. It is a thing that counts. But in for loops, generally, it doesn't always. It's not always a counter. Okay, maybe I'll have a go. So what I want you to think of I like, and by the way, it doesn't have to be I. There could be literally anything here. I could have said Jay, I could have said Harry, I could have said Obama, I could have said literally anything. Didn't quite hear that. But that is, what I want you to think of this like as it's just like another variable in your program, because that's sort of what it is. This is like saying we've got a new variable which we're going to call I, and it's a variable that only exists for the execution of these indented lines. It's like a temporary variable, kind of. And the value we're going to give it comes from whatever we've got here. So in this case, it takes its values from this range. And range basically gives you something that's basically a list from this number to this number. And I is a variable that every time we get to this line, so it goes through the loop just like in a while loop, it goes through the indented block, and it goes back to the top. But instead of checking a condition, what it does instead is it changes the value of this temporary variable. And the way it changes that is it looks for the next value in whatever list or range you have here. So in this case, you're absolutely right, it is a counter because this range goes from 1 to n, so it counts. It goes 1, 2, 3, 4, 5, it's counting. You could have a list here that had arbitrary things in it. They might not even be numbers. They could be strings. They could be other lists. They could be booleans. They could be anything. And the variable I would go through that list, and each time it went through these indented blocks, it would have the value of whatever was in that position of the list. Does that make sense? I'm seeing some tentative nods. Yes, question.
Always take of the range one after another, start from beginning or finish like randomly.
Yes, so if you use range like this, it will go from the start to the end, one by one, unless you give a third argument, which is the step. So if I put 1, n plus 1, 2, it would go 1, 3, 5, 7, 9. There are ways to produce like random numbers. We're not going to cover them in this course. If you have an immediate need for randomness, there are better ways to do it. Yes, good question though. So the question was, can you do this in a less ordered way? And you can. It's just unlikely to be useful for you guys. Is anyone? Yes.
What data type is range open bracket?
I was hoping you wouldn't ask me this.
I asked you to print it. It didn't give me a list.
Yeah, so the question was what data type is the value that range something returns? Because I've kind of been calling it a list, and it kind of is a list. It's not. It's an iterable, or it's a member of iterable. Don't worry would be my real answer. If you are interested, basically it's a member of the same class of data types that lists are also members of. So the idea is that anything here, like the thing you have to put here has to be what we call iterable, i.e. something you can iterate through.
Can I give it a list?
You can give it a list. That's why I kind of want you to think of this as a list, because you can put a list there, but you can't use range like a list, if that makes sense. So all lists are iterables, but not all iterables are lists. If you didn't understand what I just said, don't worry, because I barely do. That's a lie, but you know. Are there any more questions about this? It's okay if there are, because this is like extremely fundamental to making programs in Python, and it's not super, super simple. So if there's like any doubts in your mind, it's really good to kind of clear them up early, or as early as possible. I, still confused by I. So it's kind of like having, let's do an online one. So this program will print the numbers from 1 to 9. So what actually happens is that every time Python goes, it's sort of like, so I'm going to talk a lot about what we call like Python replacing things. It's not quite what happens, but it's kind of what happens. So if you imagine that, let's change that to a smaller number so I can actually do this. Let's go 4. So this is going to print 1, 2, 3. And what happens is that Python basically looks at this whole thing and replaces it with something that looks like this. So this part of the program, and this part of the program do exactly the same thing. They are this is more or less how Python will, what we call, unroll this loop. And this I, like we've called it I here, but this equally could have been anything. It's just saying I is a variable that we want to take the values between 1 and 4 in turn. And with each of them, it's going these things. So whatever we've got here gets put underneath this assignment. So if there was like print I, print I, print I, it would be I equals 1, print I, print I, print I equals 2, print I, print I, print I equals 3, print I, print I, print I. So what this for loop is actually doing is it's doing this line of code, or these lines of code if there were more, and each time it does it, the new variable I gets a value which is from this range, and it takes each value in turn. Does that kind of make sense? Does this kind of like loop unraveling idea make a bit more sense than whatever the hell I was talking about earlier? I don't know why I didn't do this first, to be honest. Yes?
Why is it not going to 4? I know you mentioned that.
So this is just kind of one of those things that is the way it is because someone decided it was that way. It's basically that it's inclusive on the left and not inclusive on the right. George, have you got a good reason why they chose to do that?
It's convenient.
Yeah. So if you do a lot of programming, like there's a lot of things where you'll have to you'll end up either like adding 1 or minus 1 to things a lot of the time because like you need to make sure you've got the boundaries correct. And a lot of the time when you're looping, it's more convenient for Python to do that minus 1 for you because you'll find that you're more often wanting it to have that behavior than the other behavior.
If you just want to search for array, for these, you just do layout hashing of the
Yeah, that's a good example. So the example George had there was that, like, for example, you might want to do something for every element in a list. And if you do len list, you get the length of the list, right? But we'll cover this more when we do lists again. There are like 25 pens here. Oh my God. Sorry, I got excited. So let's say you've got a list like 1, 2, 3, 4. So if I do len this list, you'll get 4, right? So if I then want to do something for every element in this list, I might do for I mean, in reality, I do for I in list, but for now, let's say I'm not. I might do for I in range 1, 1? No, 0, I'm an idiot. 0, len list. So this is the same as doing 0, 4. And if I then do something like list square brackets I in here, doing it this way means I will always get list 0 to list 3, which is, as we remember from the lists lecture, going to give us this, 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 and this. If it included 4, I'd have to then do like len list minus 1 to make sure I didn't overshoot the list. Does that make sense? Yeah, so it's just convenient, basically, but only convenient if you sort of know how to program, which isn't great if you're learning, but...
What would happen if you did overshoot the list? Would it break?
Yeah, so if you try and do something like list 5 on a, or even list 4 on this list, Python will go, no. And it'll break, basically.
What happens if you don't know how long your list is?
If you don't know how long your list is, you use, so let's say like your list is x equals 1, 2, 3, or like whatever it is, you don't know what this is. You can do y equals len x, and now you do know how long it is. So this function, len, tells you how long the list is, or any list is. Very good question.
Just for this simple range, can you make Python unravel this but in the opposite direction so instead of having one number equals one? Is there like a simple way to do that?
Yes, there is a simple way to do that. So the question is, could we make this go 3, 2, 1 rather than 1, 2, 3? There's a couple of ways of doing this. Can everyone give me the easiest? Not you, Angelo. There is a reverse function. That's where, yes, not the easiest way to do this.
Set the step as -1.
Absolutely. Gold star for Charlie. So I mentioned earlier that you can give a, at least I hope this works, you can give a step. Oh, actually, no, this isn't going to work. What do I need to change now? So this is almost right. So this third thing here is the step, so the difference between each item. So remember, if I said this was 2, it would go 1, 3, 5, 7, 9. So what's it going to do now, Charlie?
0.
Yeah, it's going to go 1, 0, -1, -2, -3, -4, -1. So what do I need to change to fix this so that it now goes 3, 2, 1? Swap 1 and 4, absolutely. So we want to start at 4 and finish at 1. We're still wrong, though. What's wrong here? If we wanted 3, 2, 1, this won't include 1. What will it include that we don't want? 4. So this now goes 4, 3, 2, because this is inclusive and this is not. So if we want 3, 2, 1, I think we want that. I hope that's right. Let's find out. Amazing. Well done, guys. Are there any more questions about for loops? Yes.
We deleted the -1 in the previous example.
Ooh, excellent question. Excellent question indeed. My honest answer is, it's probably going to do the right thing, but I don't know. So different languages will handle this differently. Okay, yeah, so Python correctly has done nothing. So I say correctly. It's done the sensible choice as a programming language and decided that because the step is 1, it can't go from 3 to 0. Other programming languages will do very different things here. This is my favorite behavior. Favorite in the sense of like least hated. Yeah. Very, very good question though. So what we actually wanted was to see if Python could replicate the -1 behavior by itself. And it can't. Cool. Let's do lists, then we'll take a break, then we'll do functions. That sound good? I realize I've been talking at you a lot. Yes. So, first question for 5 house points. What is a list an example of? We've heard enough from you, Charlie. Oh, we've got advanced answers over there. So a list is an example of something stored in the heap. So we talked last week about the stack in the heap or your label storage and your warehouse. Not quite the answer I was looking for, but you're absolutely right. Lists are stored on the heap. Let's be a bit more general than that. Yep. Operation. So they're not an operation. Good guess. Did I hear data type? Yeah, so they are a data type. You're absolutely right. What I'm going to be more specific with, I'm going to say that lists are an example of a data structure, which is a subset of data type. And I say they're a data structure because, funnily enough, they structure your data for you. There's a lot of ways to do that. Most of them you won't need to worry about unless you're in sort of my profession. So I'm not going to bore you with them. But lists are basically a really, really good way of structuring your data and doing things with it. What's good about, say, having give me one or two good things about having, say, a list of 1, 2, 3, 4, rather than 4 variables, each with the value 1, 2, 3, and 4. What's better about the list? Yep, that's a perfect example. You can do something to everything in the list very easily. What else? Yep, so you can access them based on index rather than having to know the individual names of each one. Yep.
Isn't there also a thing where Python changes the variable, uses the last one every time, or is that? Yeah. Oh, if you give them a different name, then it does that.
Yeah, so she's answered her own question for people on YouTube. Don't worry. So what do I need to know in advance if I do the variable way? What don't I always know if I'm doing a list? Yep.
What's in the list? The list can be empty.
That's true. Can we generalize that a bit more? So the answer was that the list could be empty. Could we generalize that a bit more?
No.
We can. So what else could the list be? So let's say I've called my 4 variables A, B, C, and D. What could be wrong with this? What am I able to do with a list that I can't do with variables A, B, C, and D? What if I want to save the names Harry, Lloyd, Jess, George, and Charlie? How many names was that? 5. How many variables did I have? 4. So lists are good because they don't always have you don't have a fixed length, you don't have a fixed number of them. You don't need to know in advance how many bits of data you want to put in them. So they're a bit more sort of free and structured. What a weird combo. Right, so what happens if I do x.append? Someone tell me. Adds 5 to the list, well done. Easy question. What does this mean? Empty list, was that? Empty list, well done. Someone answer this question for me? Not you, Charlie. Yeah. 4 is the correct answer. Can you explain why?
Because it will print the number in the third position, because it starts with 0. 1 will be 0, 2.
So the answer was this will print the number at position 3. And the positions in lists, as was very correctly stated, begin at 0. So this is position 0, position 1, position 2, position 3. So this prints 4. Very, very important. About len, that's fine. Can someone give me the exact definition of what remove does? Or half of the exact definition if they don't know the exact definition?
Takes out the first existence of that thing. Like, it will only take out 1.
Yeah, so a dot remove on a list will remove the first occurrence of this item in the list. So this will go through the list, it will look for a 1, and it will remove the first one it finds, and then it will stop. Here's where we started talking about warehouses for no real reason. What do I get out when I print list 2? Yep. Yeah, so we get 1, 2, 3, 4, 5, 6, because list 1 and list 2 are labels for the same list. And this is probably one of the more complex topics we've covered on this course so far, so I'm going to linger for a little bit. Can I get hands up for people who were very, very happy with my explanation of what went on here last time? Okay, that's more than I expected. So would someone be willing to explain to me, this is probably going to get fewer hands, would someone be willing to explain to me why this happens? What's actually going on under the hood here? Yep.
So you explained that there was a stack in the heap.
Mm-hmm.
The stack is the short-term memory thing, kind of.
We'll go with that.
Which stores things which are not very big,
Mm-hmm.
and the heap stores things which are larger.
Mm-hmm.
So the list 1 and list 2 are labels of something, and the something is the position of the list in the heap.
That is exactly right. You can have 100 points for Gryffindor. So, yeah, no, that is exactly right. For those that didn't hear, the answer was that last time we talked about 2 places in memory. So your computer's, well, like memory bank or its brain, I don't know. I don't do biology. Did I? Never mind. Yeah, so there's 2 places in your computer's memory, one called the stack and one called the heap. And your program will store small things on the stack and big things on the heap, because it's got more room on the heap, basically. And so when we talked about our variables as labels, what Python does is it looks at the type of the data you're labeling, and if it's small and easy to remember, like a number, like the number 5, it goes, oh, well, I can put this on a stack. It's small. If it's big, like a list, it will go, okay, well, I need to put that somewhere in the heap because it's huge. And what we're going to do is instead of giving list 1 the label this on the stack, we're going to give it just a value that points to that place on the heap. So list 1 is a label for a position on the heap. So if you think of the heap as like a big warehouse full of supplies, it's got like rows and shelves and stacks and stuff, and you're putting your lists on one of the shelves in one of the rows, and the label that list 1 actually is just like an address in your warehouse. So when you do list 2 equals list 1, you're not giving it the same list. You're not giving it a list that looks like this. You're giving it a label that points to the same place in your warehouse. And that means when you do something to this list, you're doing something to the actual list in that actual position of that warehouse, but the labels haven't changed. They still both point to the same shelf on the same row of your warehouse. This is not at all a simple concept. The idea of the stack and the heap is like super important in computing. Realistically, you don't need to know anything except that it does this sometimes with some things. If you're interested in why, and it helps you to understand why, I know personally I don't like knowing things unless I know why. So if the why helps you, this is why I did the whole stack and heap. If the why doesn't matter to you, A, I'm probably a shit teacher, and B, for you, and B, don't worry about it, because you don't need to know. I mean, you don't need to know any of this, but you know. And here's the slides explanation of that. Let's not worry too much about that. So, how do I find out if 2 lists or 2 labels for lists actually are pointing to exactly the same list? Or how do I just compare the? So if I want to do something like, let's do it on here. So Could someone tell me whether this will print hello or not? Let's start with this. Can I get a hands up for I was in last week's lecture and I think this will print hello? Can I get a hands up for I was in last week's lecture and I don't think it will print hello? I mean, a lot of you were there. I'll give you a minute or so to think about it. This is really good, by the way. You should get some of this at the break. I'm not sponsored. To be fair, if the YouTube channel takes off, these might get NordVPN sponsorship. Yes, Charlie.
How do you find what's big and what's small put in the heap stack?
So, very good question. The question was, how does Python know what's big and what's small, i.e. what goes on the stack and what goes on the heap? Can someone else answer that question? Charlie wasn't here last week. That's why he doesn't know. I hope that's why he doesn't know. Yes? It does put lists on the heap. How does it know that lists go on the heap? What is it using to decide? I mean, you're right. I think you know the answer based on what you've said. I'm trying to coax. Okay, so the answer was that it treats lists like that. It just decides lists go on the heap. What if it's not a list? How does it decide if something else goes on the heap? I think you do. Someone else, though. So, if it knows that lists go on the heap, and for example, it knows that numbers don't, it knows that integers don't go on the heap, they go on the stack. What is it using about those variables or about that data to decide? You figured it out, Charlie.
Is it using the data type?
It is exactly that. It's using the type of the data to decide whether it goes on the stack and the heap. So different data types, basically Python will know, well, this data type could be quite big, so I'm going to put it on the heap in case it ends up big. This data type can never be big. This is a number. It's always roughly the same size. I mean, that's not true when you think about numbers, but it's true if you're a computer. It's always roughly the same size, so I'm going to store that on the stack. So it is exactly that. It's using the data type to decide where to put it. Very, very good question. Right, now that you've had me rambling to think about this, can I get a hands up for it prints hello? And a hands up for it does not print hello? Okay, let's find out. Was that a hand up there? That's awkward. So Python will compare these, what we call like element-wise. So it's saying x is equal to y. So with this equal sign, we're asking, are the elements of x the same as y? But what if we want to know, so at the moment, these two lists are actually in different places in your warehouse. We can change one, and it won't affect the other. Because x and y are different labels, they point to different lists. But Python says they're the same. So what do we use instead if we want to find out if they are indeed if we want to know if they're in exactly the same position in the warehouse? We only talked about it briefly last week, so don't worry if you don't remember. So there's another command we can use instead of equals. Is. This is really nice because it looks like English. It's saying if x is y, we'll do this. And it won't print it because x and y are in different places in that warehouse. They're not the same list. If I were to do y equals x, like this, it now will print hello, because they are indeed the same list. Does that make sense to people? I'm not seeing anyone shaking their head, so I'm going to keep going. Cool. Right. Let's talk about slices. So, let's go a slide back, actually.
Wait, no, sorry, I didn't get it. How is difference equal sign?
So, don't look at the board. This is a different topic now. But the question was how, just to clarify how is and, oh, that's convenient. How is and equals are different. So equals with a list, what it does is it looks at every element in the list. And if they're all the same in the same place, then it says the two lists are equal. It says these lists have the same value. That's what equals equals means. The equals equals is asking, do the thing on the left and the thing on the right have the same value? And Python decides that lists with the same elements in them in the same order have the same value. But sometimes you do want to know if A and B or X and Y or whatever are actually the same list with the same position in that warehouse on the heap. And that's what is does. So is saying, is list 1 exactly the same list as list 2? And what it's actually doing under the hood, and you can use this as well, I didn't talk about it because it's not that important, but there's a function called ID. So remember when I talked about how list 1 and list 2 are like positions in your warehouse? ID essentially returns the address of that position. So ID is, like if you do ID list 1, this will give you the position on the heap that list 1 is at, and ID list 2 will give you the position on the heap that list 2 is at. So what is doing is it's saying, does the ID of list 1 have the same ID as list 2? I.e., does list 1 have the same address as the address of list 2? So that's what is doing under the hood. It's comparing the IDs. Very, very good question. Yes, Charlie.
Is that comparison equivalent to an equal sign or a double equal sign? Can you put ID list 1 is equal to ID list 2? Just do the same thing with the is.
Yeah, so ID list 1 equals ID list 2 is exactly the same thing as list 1 is list 2. At least as long as Python is doing like sensible optimizations, it's the same thing. Python doesn't always do sensible optimizations. They probably do that. I don't follow the Python community very well, which is weird because I'm teaching it. Never mind. So sometimes you do want to have like an exact copy of a list without it pointing at the same point in memory. And the way we do that is with taking a slice. So now list 1 and list 2 will have the same values, but will not be the same list. So when you append to list 1 and print list 2, you don't get the 6 included. Is everyone happy with the concept of taking a slice? Can someone remind me what we'd change about this syntax if we want to take the values from, say, here to here? If we want 1, 2, 3, what can we do instead? Someone different. Okay, go on then, Angela, you were first. You had your hand up first? Yeah, no, that's why I said. I've relented. No one else put the hand up. Yeah, so you can put a value after the colon or before the colon, and that will change the range that you're slicing. So you can do this. Do I need the 0? No. Just put it for clarity. You can basically put two numbers. These are the indices between which you are ranging. This won't include the 3, though, I think, because it's non-inclusive, just like we saw before. If I'm wrong, I'm sorry. I don't think I'm wrong. Right. Let's maybe take a break before we do functions. All right. So we're going to restart by looking at functions again. Can I get a hands up? Because I know a lot of people aren't, so don't feel pressured. Can I get a hands up who is happy with functions?
I'm very unhappy though.
Good. So, something which, like, I think what I'm going to do is I'm going to kind of talk about them in the same way I did before. I'm going to go through, like, the definitions and the bits and bobs. I think the problem probably, correct me if I'm wrong, like, please correct me if I'm wrong, I think the problem is probably coming in, like, what's the point of them rather than how to use them. Am I correct in assuming that? Bit of both? Okay, so I'm going to go through the, like, mechanics and the how, and then maybe I'll do a couple of examples to kind of explain the why, and then hopefully we'll have time for like an interactive one at the end. So, this on the board is a complete Python program, but as you can tell, or maybe can tell, I don't know how clear this is from your position, like, these lines are indented inside a function definition, which means that the actual program, the bit that Python actually runs, is just this bit down here. The bits that are not inside a function definition. And a function definition looks like this. So you have the def keyword, which tells Python, I'm trying to define a function now. You give the function a name, so something useful. We're going to talk more about that later. And then here we put inside brackets names for the arguments we're expecting, bits of information we're going to pass to a function. And what a function is it's a bit of code that you kind of want to just put to one side so that you can reuse it later. So it might be something that does a certain thing on a certain type of data, and you're going to want to do that a lot, and you don't want to clutter up your program with that kind of computation, or you don't want to repeat the same lines of code over and over again. Yes, let's just do an example. Let's not worry about dissecting this one too much. So the example I used last week was the triangular numbers example. So I wanted a program that would print out. Is the green pen okay for people at the back, by the way? Okay. I wanted to have a program that would print out some triangular numbers for me. And for those who want to remind what triangular numbers are, let's say I wanted the program to give me the 7th and let's think of one I can actually do, the 10th triangular number. So that should be 28 and 55. George, is it 55? I hope it's 55. So I want a program that prints out 2855, which is the 7th triangular number and the 10th triangular number. No, that's not right. I'm going to say a triangular number is basically, sorry, I completely forgot about that. A triangular number is basically, you go through like 1, 2, 3, 4, 5, and you basically add up all the numbers before it. So the first triangular number is 1. The second triangular number would be 1 plus 2, which is 3. The third triangular would be 1 plus 2 plus 3, which is 6. The fourth would be 1 plus 2 plus 3 plus 4, which is 10, 15, 21, 28, 36, 45, 55. Oh, I got it right, amazing. So it's basically like add 2, add 3, add 4, add 5, add 6, add 7, add 8, add 9, add 10. And so I want a program which gives me, in this example, the 7th one and the 10th one. And I'm going to use a function to do it. I'm going to talk about why I've used a function at the end, I think. I'm going to go through the mechanics first. So what this tells me, I want to, actually, let's say I want more triangular numbers than that. Let's make the case for functions a bit more obvious. I want the 6th as well. So I want 28, 55, 21, then I want the 8th, which is 36, and then the 3rd, which is 6. So I want 21, 55, whatever I wrote there, 21, 36, 6. So what this tells me is that I'm going to write a function which takes any number and gives me that triangular number. So if I give it 3, it'll give me the 3rd triangular number. If I give it 6, it'll give me the 6th triangular number. I'm going to write a function that does that. That's my first step. And we'll talk about why that's the first step once we've done it, once we understand what's actually happening. So what I'm going to do first, I'm going to tell Python I am defining a function called triangle, which we're going to give an n. So our n in this case will be a number. It could be anything. But n is like a variable. And what we're saying is that we're going to take n and then calculate the nth triangular number. I'm not going to worry too much about how we're doing this. So I'm just going to write this function which does this. Don't worry too much about exactly how it's doing because maths isn't important for this course. Your ability to do maths is nothing to do with whether or not you can program. So and the important bit here is I'm going to write after this return total. And so before I write the program, I just want to dissect this function a little bit. Harry, can you verify for me that that is correct? Just by looking at it, yeah. It's always nice to have a sanity check. So this here tells our Python program, so the indented bit is what we call the body of our function. So we've defined a function called triangle that takes an argument called n, and it runs these lines of code using whatever value for n it had before, just like a variable. So in the same way that we might have a bit of code that uses a variable that we've defined way up the program. And it's the same here. Like we can pretend that we've got these 4 lines of code, and n is just some value, some value we've defined somewhere up there. And what it's going to do is this like little for loop just puts the nth triangular number in total. So it goes from 1 to n, adds up each of those numbers, and gives it total. And then this here, return total, is, so it's saying that the value that total has is the value that this function returns to the program. So we give triangle an n, and it will return to us the nth triangular number. Are we following so far? So, what that means is that we can now use this function at any point in our program. And in fact, just to like really emphasize how much we don't need to worry about the function now, I'm going to like scroll down so we can't see it. We just know now that we have a correctly defined function called triangle that takes an n and returns the nth triangular number. So what we can do, if we want the 7th triangular number, is that. And we can sort of pretend that our whole program is this, and we just need to know that we've defined a function called triangle that works like that somewhere above. So now, when we're writing the rest of our program, if we want 28, 55, blah, 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 the triangular numbers that we talked about before, I just need to worry about doing this. I can't remember which ones I want. Is that 36? So now the whole program we can imagine is just this. And all triangle is a function that's defined somewhere in the same way that len and print and turns the nth triangular number. In the same way that print itself is a function that's defined somewhere. Yeah. That's okay. We're going to keep going through this. So are you able to put down what it is you don't understand? Could you tell me?
It says for I in range 1.
Oh, the maths you don't understand.
I'm not sure it might.
Because I could pick an easier function. Let's do an easier function. If it makes it easier, we can definitely do something easier.
Why do you have to put for I in range 1 to n?
Okay, I'm going to come back to this question a bit later on because it's going to distract us from this topic. What I'm going to do is to simplify this, I'm going to change the example. Rather than doing triangular numbers, we're going to double numbers. So let's say we have, rather than triangling, we're just going to print all of these numbers times 2. We're going to double all the numbers. We're going to print 14, 20, 12, 16, and 6. I think the triangular numbers is just confusing stuff. Let's not worry about that for now. So this example is a bit simpler. All we're doing, this function, we're saying we're defining a function called double. It takes an n, it adds n to itself, and it returns to the program the new value, the total, which is n plus n. So this means when we call these double functions, we're passing each of these items to a function called double that does exactly that with each of them. And what this return means is that when we've called the function, this whole function call gets replaced by the value that is returned. So double 7 replaced by 14. So it becomes print 14. Double 10 gets replaced by 20, so this becomes print 20, and so on, which is why we get out 14, 20, 12, 16, 6. It was the maths. Okay. I'll stay away from maths. Yes, Charlie.
Would it is it possible, I was just thinking in terms of it might be a bit simpler, because the point of the defining function is to reduce how much code you're typing.
Mm-hmm.
There you print double print. Could you not just give it an input to list?
You could.
Would that not?
You could exactly do that. So Charlie is saying, well, we've got a lot of things we want to double. Why couldn't we say that we don't give it a single number, but maybe a list of numbers? Can you see where I'm going with this? I'm not going to complete the example, actually, because I think I want to make sure people have nailed the basics first. We will come back to that. I'm going to come back to that exact question. Sorry about the twist and turn there. Very, very good question. I don't know if we're rolling, by the way, because George has disappeared, but the camera's still there. There's a light on it, which I think... I was about to say, if you're on YouTube, can you put your hand up? Can you tell I'm tired? Yeah, I will come back to that question, Charlie. I want to make sure everyone's okay with the mechanics first. So can I get a hands up if you're not happy with like what this 3-line section of code means, what I'm doing at the top here? Can I get a hands up if you are happy with those 3 lines of code? Oh, that's most of you. That's very pleasing. Is that a question, or are you just still happy?
Can I just ask, what's the difference between print and return? Why wouldn't we use print and return?
Yeah, so print and return. The question was, what's the difference between print and return? I'm going to show you by example. Let's say we didn't just want to print out numbers. Let's say our program had a variable called, 7. And you know how before we had like is big equals bigger than. We could do things like this, right? Well, maybe we're actually interested in whatever x times 2 is. And this isn't going to print out 14. This is just going to use the value 14 now for our calculation. Basically, the return statement here is not what prints out here. This return statement here just tells the program what to replace this with. So it means the double x here gets replaced with double whatever 7 is, which is 14. So now is big equals 14 greater than 10, which is true. And now we can go on to use is big in the rest of our program. So by using return, we're telling the program how to sort of interpret what we mean when we say double. The reason we used print outside was because we wanted to kind of show that we were getting it right. But we won't always want to print stuff. And in fact, most of the time, we don't want to print stuff. We only want to print stuff if we want to tell the user something. Very good question. Are there any more questions about this kind of stuff? I'm going to keep talking about functions for a little bit, so don't worry. Okay. Would I be right in saying that people are mostly happy with like the mechanics of writing a function and using a function? Is anyone unhappy? If I said to you, write a function that does something, would you know what you needed to do? Yeah, let's do that. I want you guys to write me a function. I'm going to stretch you a little bit. I want you to write me a function that takes 2 numbers and adds them together and gives me the result. Actually, no, let's do two questions. Two questions. That's the second question of two. The first thing I want you to do is give me a function, write me a function that takes a number and triples. The second question is to write a function that takes two numbers and adds them together. If you need help, whack your hand up and one of our helpers will come to you. But not George because he's ill. So your program at the bottom, I want it to look something like this. I want you to give me 15 for that. And 8 for that. So what you define the functions triple and add is I'm going to do this exactly what you guys have just done. Actually, no, let's pick on someone. Who said they'd done both of them? Do you want to come to the front? You can bring your laptop, yeah. What's your name? Tilly. Can we have a round of applause for Tilly? Both of them. All right, so Tilly's going to write the functions, and I'm going to have a go at explaining what's going on. So we know that we need to define a function called triple. So that's exactly what Tilly's doing. She's telling Python to define a function called triple that takes something called n. So it takes an argument called n. And she's going to define a new variable inside this function called total, which has the same value as 3 times n, which is triple n. And she's going to return that to the program. Now when we call triple 5, keep going, Tilly. Now when we call triple 5, it's going to call that function, and it's going to replace triple 5 with 5 times 3, which is 15. So now when we do add, I've said I want you to add two numbers together. So this is a little bit of a stretch. You can pass more than one thing to the function. You can have more than one argument. And that's exactly how you do it. You do a little comma. So now add takes two numbers, n and m, adds them together, returns a total. So now if you run this program, it should work. Ta-da! Well done, Tilly. I'm making myself cringe. Right. So that is 100% right. Well done. That is exactly how you do it. So did most people get something like this? Can someone who didn't manage it give me a wave if they now understand what they didn't understand? Actually, no, let's do that the other way around. If you didn't get it and you still don't get it, can you give me a wave? Nice. That was a little wave. Just a fun wave. Okay. Right. Charlie, can I have that question now, please?
How does it know what?
Yeah. So the question was, how does it know that n and m are numbers? Does someone else want to take a stab at that question? It's kind of a trick question.
Because you gave it numbers.
Yeah, so I gave it numbers. That's how it knows they're numbers. So in this particular example, it goes, well, triple 5, so n is 5. 5 is a number, so it does it like as a number. Could I have given triple a string?
Yes.
Yeah. So I could have given triple a string, and it would have done that string times 3. So if I'd given it Lloyd, it would print Lloyd, Lloyd, Lloyd. So Python, unlike most sane programming languages, actually I don't even know why I'm including Python in sane programming. Anyway, Python doesn't know what data types functions work on. It will just take whatever you give it and do whatever it thinks is best. So if you give a function a string, it's going to try and use it like it's a string. It's going to go, well, this is a string, I'm going to keep going as if this is a string. Not super important, really, other than that you just need to be aware of the fact that if you're writing functions that somebody else might use, which, unless you're in industry, isn't super common, but could be if you're like, I don't know, you're doing research for someone else, or whatever, you need to be aware that they might not pass the same data type to your function that you were expecting them to when you wrote it. It's just something to be aware of. In the same way that I could add, Lloyd and is rather sleepy. And it prints that out. So it's not what we were expecting our function to do, but it just happens to do the same thing. How happy are people feeling about the mechanics of functions now? People know how they work, what to do with them. Okay, yes, Charlie.
Say you defined a function ages ago and you want to call it to do something later,
Mm-hmm.
but you can't remember what the inputs are. Is there a way of, without going back up and looking at it, checking what the inputs of the function are?
Yes.
Say it's got two inputs and three.
There are. I'm not going to go through it now because it depends on what editor you're using. In the same way that, like, when I started typing, for example, list.reverse, a little pop-up window came up that told you about the function. You can make Python produce those for your own functions. I'm not going to go into it now, though, mostly because I don't think many people here will end up writing programs so complex that it's actually difficult to just scroll to the top of the program. Very good question. So the question for YouTube was, can you make Python tell you what arguments your function takes after you've written it without scrolling up? And you can, but I'm not going to bother covering it. So, why did I delete everything? So the other question I've got, let's pretend this is double again. The other question I've got is, can I use a function inside a function? I heard a yes. That means you already knew the answer. It's people who didn't know. Could I do, for example, could I do this? Hands up for yes, this will definitely work. Hands up for no, this definitely won't work. Hands up for I've given up caring, it's nearly 8 o'clock. Hands up for I don't know. Wow. Hands up for I'm not listening. Okay, so yeah, the answer is we're absolutely fine to do this. We can reuse functions inside other functions. So another question which I've got, which I'm not going to answer this week, I'm probably going to answer it next week. Can I use a function inside itself? I'm seeing a, yeah, I think you can from the front. The answer is yes. It's not immediately obvious why we'd want to, but yes, you absolutely can use a function inside a function. We're going to cover that next week. It's called recursion. It's a word you might have heard of before. And it's like my favorite thing to teach in the world. So I'm really excited for next time. The one thing I want to cover before we finish, though, is why. Why are we writing functions? And the simple answer is in lecture 6. We're going to go through it in more detail. The simple answer is this. Where's my stick? Where's my stick? This on the right does exactly the same thing as the thing on the left. It's just we've defined some functions which will be above it. If you want to understand what this program does, you only have to read this. And you might not know exactly what reverse append n elements and append new elements do, but by looking at it, you can get like an intuition of what this program does. If you look at this, you're going to be there for at least like 5-10 minutes, even like reading it, let alone understanding it. So the idea is that functions are one example of what we call abstraction, which is the topic for lecture 6. It's one example of abstraction that basically makes your code easier to follow and more reusable. So the other thing as well is you can use functions elsewhere. So I might have a function that does something really clever, and I might think, oh, well, this function's so clever that Harry might want to use it. So I can like send Harry just the functions, and then he can use it however he wants to. Next week, we will see some really interesting stuff. Like, no, not next week. I'm in Amsterdam. The week after, which is the next session, we will see some real-world examples where we will use functions a lot, which is why I wanted to cover them. The reason I'm sort of stopping now is because it's nearly 8 o'clock. I wanted to do a couple more examples, but we might do them next week instead. Not next week. I'm in Amsterdam. 2 weeks from now. Yes. Back. So this was our goal for the lecture. I think we've done that. We've covered all of that. We've briefly talked about this right at the end. And I think we can do that. Can I get a hands up if you don't agree with what I've just said? Is anyone unhappy with anything that's on the board? George, what are you unhappy about? Is anyone other than George unhappy with something on the board? It's okay if you are. Because if you are, it's my fault. And I would like to fix that. You don't like the colour scheme? I didn't do the colour scheme. Not my fault. Excellent. Okay, well in that case, we'll wrap up there. If anyone has any questions before the next session, which is in 2 weeks' time, not next week, feel free to shoot me a message. Videos and stuff will be up, I promise. As soon as George is less ill, bless him. He's still here, just. So they will be there. They will be there, I promise. Feel free to message me on something, Facebook, email. You can find me on the Imperial system. I will literally do anything to not do my dissertation, so feel free to ask any questions. I think there's a computing bar night now. Are we going to that, George?